Hi everyone, welcome to another Colonial 1 tutorial. In today's tutorial, we're going to look at submitting a batch job using our scheduler, Slurm. I'm going to use an MPI example for this particular tutorial, but that's not really what's important. This works for any sort of executable. What is important though is the submit script that I'm going to use to send my job off. So let me open up my editor and show you what a submit script would look like. Our first line is a shebang line. It just lets the interpreter know that this is going to be a batch program. The next several lines are our sbatch directives, and those begin with the #, sbatch in capital letters, and then whatever directive you want to give. Now it's important to note that in order for an sbatch directive to be read correctly, it has to have this format. No spaces. So for example, if I were to do the following, this would then, the first line, would then be commented out. The first sbatch directive anyway would be commented out. As would this. This would also be interpreted as a comment. This is the correct form to use. So you can see right away I have some lines commented out. 3 lines in fact, but we'll get to those momentarily. In the first line, I'm setting up an example.out file. So what happens here is, because I'm giving the -O flag, that means that any output which would have gone to standard out will get redirected to my example.out file. The %J is a variable, and that variable gets interpolated by the job ID number. So suppose my job ID number was 123. My output file would read example123.out, and in it will be all of the information which normally would have been directed to standard out. Same thing for the next line, except this time we give the -E flag. What this means is that any standard error messages are going to get redirected into example123.error, assuming our job ID is still 123. In the next line, I have the -P option, and this is for partition. I'm going to be submitting this job to the debug queue. To remind you, the different partitions can be found in the first column after supplying the sinfo command. In my example, I'll be submitting a job to the debug queue, so one of these nodes, either 991 or 992. In the next line, I have the -N option, and this means the number of nodes that I'm requesting. I'm only requesting one node for this job. The next line is -n followed by a number, in this case 8. This tells Slurm how many tasks to expect to be launched. sbatch doesn't actually launch tasks by itself, but it makes sure that the resources are available to launch, in this case, 8 separate tasks. Of course, I have this line commented out, so it's not going to do that at all. The next line is our -D. This tells Slurm what working directory it should be using. This is the directory where I have my codes, my executable, etc. The next line, -J, followed by a string, allows me to tell Slurm what the job name should be. This just basically allows me to name my job. This job is going to be called MPI test. If you don't supply the -J, Slurm will use the name of the submit script as the job name. The next line, --export equals none, which is optional, lets me tell Slurm not to export any of my environmental variables to the job allocation. The next line is a critical line, -T. This is where we specify the maximum time limit for our job. So in this example, I'm saying my job, it's basically a promise that I make to the scheduler saying that my job will be done in 10 minutes. And if it's not done in 10 minutes, you can go ahead and remove it. The next line is the amount of memory per CPU in megabytes. This goes out and finds nodes for us that have at least this much RAM available for our job. I have this line commented out as well. I'm not going to be using that for this example. In this line, I'm setting up a job array. Job arrays are a very interesting option, and I'll be spending time in a later tutorial focusing just on job arrays, so I won't say much about them now. The last sbatch directive here allows me to change the nice value of my job. This is useful working in collaboration with other people in the same group who are using the same resources. In the last few lines here, I'm going to load my OpenMPI module. Now you notice I have a line commented out here. The reason I have this line commented out is because this line, the dash capital D line, takes its place. However, I could, to get the same effect, by doing the following. But I like the way that I had it, so I'm going to go back. In the last line, I'm going to start MPI in the usual way using MPI run. I'm asking for 8 CPUs, and then I give my executable name. So now we're ready to submit our job. SBatch, followed by the name of the submit script, and if all goes well, we'll be given a job ID. So this job's going to go pretty quickly. Let's see if it's returned yet. Ah, there it is. Our job has finished. Excellent. No errors. The file size is 0. That's good to know. Let's open up our results and see what they look like. Ah, and there they are. That's exactly what we expected. Okay, so that wraps up our tutorial using Slurm in batch mode on Colonial 1 to submit a job.